Hey there, quick video on how to put an auto drain on a 220 volt air compressor like this Speedaire 60 gallon. These instructions should work for just about any air compressor that's driven by a pressure switch, this guy right here, that tells the motor when to fire when the tank gets below a certain pressure. So I'm going to do a quick video on how it actually works, and I'll walk through the different components of it, and then I'll show you how it can be done for relatively cheap. So first off, why put an auto drain on an air compressor? What I'm showing you here is a ball valve that most manufacturers put at the bottom of these tanks. And the problem is, no one ever goes down there, no one ever empties that, at least not as often as they should. And what happens is every time your air compressor is on and cycling, it's pulling in a lot of air. With that air comes a lot of moisture. I'm fortunate to be here in the Pacific Northwest, so it's not a super humid environment. But if you're in a humid location, you know, that problem is a much bigger problem for you. So having an auto drain is just a big convenience because you don't have to fiddle with getting down on your knees and trying to spin that valve and then getting a bunch of gunk in your face. So you can go on Amazon and get a lot of cheap kits that do this, but the problem is they all run off of 110. And I wanted a system that would just run off that single plug, right? That single 220 volt plug going into the air compressor. So that's what I've accomplished here with this system. So all the components I'll go through here are all designed to work at full voltage, 220 volt. And you know, you can also see that I've done my best to kind of jacket the cables and keep it clean. I figured since it is going to be, you know, 220, it's probably best to do what I can to seal it off as well as I can. So do keep in mind whenever you're working on the electrical system here, you always want to unplug this. Always. So that's the first step I always did before I touched anything here. And I'm still alive today. So auto drain 220 volt air compressor, and here we go. I'll go through the components here and even show you how it works. Okay, so I've thrown some bubble wrap down here just to depict when this thing fires. You'll see it kind of flying in the wind there. But what I'm going to do is this is fully, this tank is fully pressurized, so I'm going to drain some of the air out of it, and then I'll resume the video just before it turns on so that you guys can see what it looks like. Okay, so you guys saw how that worked. Just as soon as the motor turned on, what I was doing was I was draining the air out of it, and then when you saw that fire, that was the first 2 seconds of the motor starting, and then it continued to cycle on. So now I'm going to go through the components and I'll show you how they're wired. Okay, so the first important component here, I replaced this ball valve with what you can see down here is a solenoid, and you can see it better from this angle right here. This is an ASCO Red Hat unit. This is more expensive and kind of unnecessary level of industrialness for this application. So I'll link to an Amazon one for a cheaper solenoid. But essentially, you want a normally closed solenoid, and you want it to have 1/4-inch NPT fittings. And again, I'll show you the link for that. What you can see is I've just gone to the hardware store and got some 1/4-inch NPT extensions there, and then this is an elbow that perfectly fits the bottom of that air compressor. So this is a compressor switch and motor, and I'm going to take the plate off of this motor right here, just those two screws, and then I'm going to pop this screw off here to take the lid off of the switch, and you can see how this was wired. Okay, so with the switch and motor housing exposed, you can see how I wired this, and again, probably a cleaner way to wire it, but this is what worked for me. So the solenoid down here has 3 wires. It's got 2 reds and a green. So it's coming up here, and you'll see both of the reds are coming out of this cable gland, and they're going down and eventually going back into this control box. So I'll show you how that's wired there in a moment. I do have the ground from this going up and into the ground screw on the motor housing. Now, you can probably put it anywhere on the body down here. I might have been able to screw it down into one of the feet, but I just didn't want to take any paint off, and you know, I might use these feet for something else in the future, so I wanted to Make sure that it had a good ground there. So that's one of the wires coming off the solenoid. And here in the housing, you can see that I am bringing one of the black wires from our control box over here into the L1 on the motor switch. We'll show a wiring diagram on that too. And then we've got the white coming out of the control box and coming up here and into, it's spliced into L1 right now, which is actually this black cable right here. I do recommend the use of spade terminals, as I'm using right here for this black wire, simply because it's tough to just, you know, get a wire shoved in there, especially one with a lot of strands, and then tighten that down. And then over the long term, this thing's going to be seeing a lot of vibration, so you don't really want to have a connection like that. You can see another spade terminal used right down here. I'll include that in my link of hardware so that you guys can kind of see hopefully everything you need to order to finish the job here. This is the control box for the timing relay. Alright, so you've seen where the wires go to. You got the two reds in here coming from the solenoid. And because this is dark in here, what I'll do is I'll show a pop-up image, give you a better idea of where they connect to here. Okay, so this is a good picture of the inside of the control box. You can see the Omron H3Y timing relay there. Be careful and order the one that's in my description. Don't order or don't just try and do a Google search, because this H3Y-2 timer comes in a lot of different models. You want to be sure to specifically pick the one with the 0.2 or I believe it's 0.1 to 5 seconds of adjustability. They also make a model that's 1 minute to 30 minutes, and it does not provide a fine enough adjustment for this application. You'll also see some twist tie connectors there. I generally don't like to use those, but because this is 14 gauge wire here, it's really too fat to stick two wires underneath a single terminal there on the switch. So in one case there with the two blacks and a green cable, that's actually jumpering two terminals there. So you'll see that in the wiring diagram I'll show you in a minute. But the other twist tie there is actually just basically taking two wires into one that then allows me to cleanly put that into the single terminal on the switch. The other thing is you'll see some DIN rail here. Probably unnecessary, but because this switch is going to see some vibration, I just wanted it planted. I didn't want it kind of bouncing around in the box, so I just got I think a 1 foot piece of DIN rail, cut it down to size, and this case is nice and accommodates that. Okay, so now we're displaying the wiring diagram. I'm not an engineer by trade, so you're not going to get the engineering shorthand version. You're going to see the fancy marketing version. So we've already talked about the solenoid valve. You got 3 wires coming off that, 2 reds and a green. We've already talked about where the reds go. They go into the control box and specifically into terminals 9 and 14 on the Omron switch. So on the far left there, you'll see the front or top view of the Omron H3Y-2 terminal numbers. So you would just map those red cables into those terminals, with the green, as we've shown in the video, going up to the motor ground. Jumper there in purple is just that. It's a wire that is only connecting terminals 1 and 13. You're just bridging those connections within the control box for that timing relay. So that cable does not need to leave the box. It's just a depiction there. So in the blue there, you'll see the pressure switch connection. That, as we showed in the video, is actually the white cable in the video. So that is going from the pressure switch L1 into the control box and connecting to timer terminal 14. Again, that is the white cable in the video. I should have made it a blue cable. It would have been a lot easier. And in the black there, that is the black cable in the video. That is the cable going to the motor L1. So that's going from the motor L1 to the timer terminal 13. So I think that shows the basic wiring diagram. I did list also some recommended components on the right there. So that should be everything you need to really complete the installation in most compressor applications like this. So if you're doing a horizontal air compressor, not an upright,
you know, you might have a different length of wire, you might want to pick a different control box housing. That's really up to you, but things like the solenoid valve and the timing relay are probably going to be things that will work in just about every application here, as long as we're talking 220 volts. So I'll put a link to this wiring diagram image in the YouTube description in case you want to print it out and use it as reference during your installation.
Hey, just one last note. I want to show you guys something cool. This is a muffler, and it's 1/4 inch NPT male threaded. So I don't have the right connection here to hook this up yet. I need to get a female to female connection, but this really does work well. I've used it in another air compressor. It cuts down substantially on the noise, and you know, the problem with an auto drain like this is it's firing when you're not necessarily expecting it to go off, and it can make you jump. So having a muffler on it like this, not a bad idea. This is, you know, $8 or something like that on Amazon. I'll send you guys a link to it. But a good add-on here, and again, I need to kind of modify my fittings here because it's going to be too close to the ground. So I've got to get a couple different fittings, and then I want to eventually have this blasting into a pan, a drip pan, drip tray, something like that, rather than going right onto the floor. But really the idea is, you know, with this auto drain, you're never going to collect a lot of moisture anyways. So I'm thinking what spews out of here is probably going to be pretty much instantly evaporating. So there you have it, an auto drain on a 220 volt pressure switch driven air compressor. Hope this video was useful to you guys, and do leave a YouTube comment down below if you found this to be helpful. And if you got any ideas on improvements, I'd love to hear that as well. Thanks for watching.